During this video, we will see how to obtain the graph of sine theta. Last time we saw how to define all the trig ratios using x, y, and r. We are going to need those definitions for this discussion as well. Therefore, let's quickly revisit the definitions of trig ratios using x, y, and r, and then we will talk about how to obtain the graph of sine theta. First of all, we wanted the OXY axis. Then we wanted a circle centered at the origin right here, and the radius was equal to r. Let's assume that this is that circle of radius equals r. Then we wanted a line segment coming from the origin O until its circumference. Let's say this is that line segment. And we labeled this point right here on the circumference as point P, and the coordinates of that point were labeled as lowercase x and lowercase y. We labeled the angle right here as angle theta, and we said when we measure that theta counterclockwise from the OX axis, it was positive, and if you measured that angle clockwise, that's going to be negative. And then we drew the perpendicular line from P onto the OX axis. We showed that the angle right here is 90 degrees, and then we said the length right here should be equal to x, and the length right here should be equal to y. Of course, the radius is equal to r, therefore this length is equal to r. Then we said sine theta can be defined as y over r, cosine theta can be defined as x over r, and tangent theta can be defined as y over x. During the discussion today, we are going to look at the graph of sine theta. Therefore, for the discussion today, I will not need cosine theta and tangent theta definitions in terms of x, y, and r. I will simply need the definition of sine theta as y over r. Now, I have a question for you. What's the largest possible value for sine theta? In order to answer that problem, you have to understand that the denominator of sine theta, which is equal to r, is always a positive value. Why? Because r is the radius. Radius cannot be negative. Therefore, the denominator is always positive. Now, what are the possible values for y? Y was defined as the vertical height right here. As theta changes, we have to pay attention on what happens to the values of y. Let's say theta was 0. If theta was 0, the point P cannot be somewhere there. That point P should be on the x-axis, just right here. If point P was right here on the x-axis, the y value is equal to 0. So remember that y could be equal to 0. But is that the lowest value that y can take? Think about the case where that theta is equal to 90 degrees, or in other words, pi over 2 radians. In that case, the point P is going to be on the y-axis right here. When the point P is right here, what should be the vertical height? The vertical height is y, and that y should be equal to the radius r. That has to be identified actually as the upper limit of y. Therefore, let's take it down. Y can also take the value of r. Now assume that theta is increased even more. Let's say now theta is equal to 180 degrees, or in other words, pi radians. In that case, P should be right here. If P is right here, what's the y value? Y value is once again the vertical height between the OX axis and the point P. When the P is back on the OX axis, y is going to be once again equal to 0. Now we will look at the other possibility. Think about the point P is going to be on the y-axis but on the back side right here. In that case, what should be the value of y? The numerical value of y should be equal to r, but that value is on the negative side of the y-axis. Therefore, now the value of y has become equal to negative r. Please note that r didn't become negative, okay? R stays as positive. Only the y value has become equal to negative r. Alright, now these are the extreme values of y. When y takes those extreme values, now we can address the possible range for sine theta. We know that sine theta is equal to y over r. When it is y over r, sine theta can take 0 divided by r, which is equal to 0. Sine theta can take r divided by r, which is equal to 1. And sine theta can take negative r divided by r, which is equal to negative 1. Therefore, quite practically, we can see that sine theta is going to be bounded between negative 1 and positive 1. For the graph of sine theta, I'm going to obtain a special circle. R is the largest possible value each of the two variables, x and y, can take. Now, without loss of generality, I'm going to let r be equal to 1. If r is equal to 1, now that circle is called the unit circle. Let me draw that unit circle real quick. That's our OXY system, and I'm going to need a unit circle, which means a circle whose radius is equal to 1. Here is that circle. Now, can you identify these endpoints? What should be this endpoint? The coordinates of that endpoint should be x coordinate is 1, the y coordinate is equal to 0. Right here, the endpoint must have 0 as x coordinate and 1 as the y coordinate. Right here, x coordinate should be equal to negative 1, the y coordinate is equal to 0. Right here, the x coordinate is equal to 0 and the y coordinate is equal to negative 1. Why all of that? That is because the radius of this circle was taken as equal to 1. I hope finding these coordinate points is not a difficult task. Now we need theta. Let me draw an angle theta. For the simplicity, let me draw it in the first quadrant. Let's say this is that straight line, and I have point P right here. Let me label the coordinates as lowercase x and lowercase y for the point P. Theta is the angle right here. When measured counterclockwise, we know it's positive, and if measured clockwise, that should be negative. Now, if we revisit the definition of sine theta, we defined sine theta as y over r. However, for this case, the radius r is equal to 1. Therefore, our sine theta becomes just equal to y. When sine theta is just equal to y, if I need to draw the graph of sine theta, I simply have to look at this y. How does y change? If I can figure that out, then I'm done. I can obtain the graph quite easily. That's the whole reason why I selected a circle with radius equals 1. The name of that circle is unit circle. Now, using this unit circle, let's see how to obtain the graph of sine theta. I'm going to need this x-axis, and I'm going to need the y-axis as always. Right here is the origin, and I'm going to label the x-axis as axis theta. I'm going to label the y-axis as the axis for sine theta. Like we saw earlier, what are the possible values of the sine theta? Sine theta can take values between negative 1 and positive 1. We discussed that one using a circle of radius r. Now, if you look at the unit circle, y coordinate can be seen as the second of these pairs of coordinates. And right here, the y coordinate is equal to 0. For this coordinate, y coordinate is equal to positive 1. Right here, y coordinate is once again equal to 0. Right here, the y coordinate is equal to negative 1. That also confirms that sine theta, or the y values in the unit circle explanation will always be within -1 and +1. Therefore, I'm going to go ahead and draw the boundary, upper boundary as +1 and the lower boundary as -1 for the graph. Let's assume this is the upper bound. Now I need the lower bound. Let me assume that this is the lower bound. The point right here is upper bound, which is +1. The point right here is the lower bound, which is -1. Now I need to show the values on theta on this axis. When the point P is somewhere here, theta is equal to 0. When theta is equal to 0, what's the value of y? The value of y is equal to 0. That means 0, 0 is a coordinate point on the graph. This point is on the graph. Now, what are the other important points? The point P right here may move to the position right here, 0, 1. In that case, your theta is equal to pi over 2. Let me show pi over 2 on the graph. When theta is equal to pi over 2, what's the value of sine theta? When theta is equal to pi over 2, sine theta, which is given by y, is equal to 1. Therefore, as theta takes the value of pi over 2, sine theta is going to be equal to 1. It's going to be right here. And then the point P can come to this place as well. In that place, sine theta, which is given by y, is equal to 0. In that place, theta is equal to pi. Therefore, let me show pi somewhere here. At that place, theta is equal to 0. Therefore, this point is a point on the graph when theta is equal to pi. Next position for P is right here. In that place, theta is equal to 3 pi over 2. When theta is equal to 3 pi over 2, sine theta, which is given by y value, has become equal to -1. Therefore, when theta is equal to 3 pi over 2, the y value, the sine theta value, is equal to -1. And finally, the point P can come back to this place. When point P completes a circle and come back onto the x-axis, theta is equal to 2 pi. When theta is equal to 2 pi, sine theta value, which is given by y, is equal to 0. When theta is equal to 2 pi, the sine theta value is equal to 0. Now, we will go ahead and draw the sine curve for the values of theta between 0 and 2 pi. We know that it has to start right here and then reach the point right here, then come back to the point right here, then reach this lower point, finally end up at the x-axis itself. But how do you connect them? Are we going to draw the straight lines like this or some curves? We have to pay attention on that part. In order to decide that, we have to look at the variability between each of these intervals. If you look at the variability between 0 and pi over 2, what actually has happened? The y values are going to increase. That is true. Like this, the y values are increasing. However, as theta is close to 90 degrees or pi over 2 radians, the rate of increase has become low. Therefore, we have to draw it as a curve between these intervals, and as it reaches the top, as it reaches these kinds of points, the rate of increase decreases. Similarly, you can look at that same characteristic as it reaches a point like this, the lowermost point. In that case also, the rate of change decreases. Therefore, to preserve that characteristic, the graph should be drawn like this. In case if theta wanted to go another complete round like that, the shape of the y values will exactly be the same as this. It will just be repeated for some more values to the right hand side. Therefore, we agree that the period for sine theta is equal to 2 pi. Remembering the period of sine theta as 2 pi is very important. However, don't just remember it as period equals 2 pi. Try to remember completely as the period of sine theta is equal to 2 pi. Because in the future, rather than just sine theta, you may also need to see sine 2 theta, sine 3 theta, and so on. In such cases, the period changes. Now, I'm going to extend this graph a little bit more. Think about that theta is going to rotate clockwise. That means theta starts from the x-axis and it now wants to go like this and come back onto the x-axis. In that case, theta will be negative. You will see that this pattern right here should be now extended towards the left hand side like this. We will see how to draw that part real quick. I will once again need those coordinates like pi over 2, pi, 3 pi over 2 and 2 pi. I will need those values onto the left hand side as negative values. So let me show negative pi over 2, negative pi, negative 3 pi over 2 and negative 2 pi. Now when you pay attention on sine theta, or in other words the values of y, you will see as theta is negative pi over 2. Negative pi over 2 means theta started on the x-axis right here, came up to negative pi over 2 right there. The y value is equal to negative 1. Therefore, this point is going to be on the graph. Similarly, as theta is equal to negative pi, that means theta is back on the x-axis on the left hand side like that, the y value is equal to 0. Therefore, this point is on the graph. And then as theta equals negative 3 pi over 2, that means right here is theta, back on the y-axis on the positive direction. When that happens, the y value is equal to 1. Therefore, sine theta is equal to 1. Therefore, when theta is equal to negative 3 pi over 2, we have sine theta equals positive 1. And finally, when theta is equal to negative 2 pi, that means back on the x-axis like this, once again, the y value is equal to 0, which means sine theta is once again equal to 0. Therefore, that curve comes back onto this place like that. Now, when I draw that graph, I need to connect these points. So let me draw it for the left hand side. Alright, now I have completed the graph of sine theta for 2 periods. There are 2 important things. We already saw the period of sine theta. The period of sine theta is equal to 2 pi. And then it's also equally important to identify the amplitude of sine theta. Amplitude of these kinds of curves is defined as the distance to the peak, the furthest distance from the center line. The center line is right here. A set of most distant points can be found at the upper limit. The other set of most distant points can be found at the lower limit. We need to find that gap between the center and the topmost place, or the center and the lowermost place. Now, in this case, we know that this length right here should be equal to 1. And similarly, this length right here should be also equal to 1 by magnitude. It's only the magnitude. For the sine theta curve, the amplitude is equal to 1. Alright, that's how the sine theta graph can be drawn. Once again, please remember that there is no reason to start the sine curve at negative 2 pi or to end the sine curve at positive 2 pi. I just randomly started at negative 2 pi and randomly ended at positive 2 pi just to ensure that I have drawn it for 2 complete periods. But when you draw it, you have the freedom to decide the starting point and ending point. However, when you draw these kinds of curves, please try to go at least up to 2 periods. Alright, let me end this video at this point. Thank you so much.